Hello, how are you doing? Okay, so well, let's start. The others may join if they like. So we have a new TA. So yeah, not there yet, but hopefully next week we'll have. It's not going to be me. Not that I don't enjoy doing some math, but I think for you it's good to have multiple perspectives and stuff. So I have posted a few minutes ago the homework assignment number 1. Some questions I think are interesting, which is not necessarily a good thing for you. It means it's a bit, it's I don't know, might be a bit challenging, but yeah, most of it should be doable, I think. If you have problems, really, you can. The thing is, you have to work on it a bit, and if you're really blocked, you don't know how to do, then you may like ask me and say, yeah, please give me some hints. Here's what I've done so far. So the goal is for you to learn, of course. So yeah. But of course, you cannot just say, oh, please, I don't know anything. Tell me what the answer is. That won't do. All right. About the tutorial 1, so I've realized that, yeah, some notation was old notation that I've just updated. So yeah, nothing too important. Okay, so let's go with. So here's how I think I'm going to do. So I'm going to have to split my screen this way, and have some questions here and answers there. Actually, I don't really know how I should be doing this. So I should be asking you questions about it, I guess. So so let's just have this there. Does that work? E equals 456. B equals 3, 4, 5, 6, 7, and C equals 2, 3, and 6. So did anybody have had a hard time with this one? So verify the distributive law. So I want here A union B intersections. So who knows what I should be doing there if I want to, if I'm telling you verify the distributive law. No clue?
Okay, we start with the parentheses and then we find the intersection between V and C.
Yeah, so okay, so what you're saying is we should, so basically we should just substitute this into these and then compute it, right? But so that's the first step. But here what I'm asking is verify the distributive law. So what would that mean? It's a good answer. It's a first step, but it's not the whole thing. No idea. So if I tell you verify that this like this bag has as many objects as this bag. So counting the objects in bag number 1 is not the whole thing. So what I'm asking you to do is verify something. So what is the distributive law? Somebody remembers?
Yeah, so basically we have to put it equal to A union B intersection A union C.
Yes. So we verify that for A, B, and C, we have that this equals to A union B intersection C. Yes, so this is the distributive law. So what we want to do is so verify what this is, and make sure that they are equal. So somebody has tried it. So just one, for instance, this equals to. You can say it in the chat if you have the answer. I can leave you sometimes to compute it on your own. Yeah, maybe that's going to take a bit too long. But so how long are supposed the TA session supposed to be? So I think it's an hour, right? Yeah, that's what I wrote. Because so anyways, don't panic. Anything that we haven't time to do in class, I just post the answers. So thing is, this is there to help you, so it's not there to torment you or anything. All right, so I could show you. All right, good. Thank you, Mr. Jadbaba. So this is equal to 4, 5, 6, 3, 4, 5, 6, 7, and 2, 3, 6. So yeah, let's do this way. So order of operation. So this is equal to, so we start by finding the common elements of these two sets. So 2 is not there, 3 is there, 4 is not there, 5, no. So just 3 and 6, I think. And then this is equal to, so I take the union. So here I'm going to add the 3 in front of it. Did I make a mistake? Yeah.
No, I think it's correct. I just missed the 5.
Yeah, that so really there's one way to make sure you don't make a mistake is you verify. So not going too fast. So that's the key. And then you would try the same thing with this one. So let's again here. Yeah, so I think what I can do is do one of each, and then the others you have the answer, because really the other is just doing the same thing with just a slightly different stuff. So I think I'll just do 1A, 2A, 3, 4A, and maybe A and B, and then 5, some of them. And then if we have time, we can go back to the others. How's that? Of course, if there's one in particular you want me to do, then I can do it. Let's see. All right, so let's start by taking the unions here. So basically, this is the larger set, so I'm going to add these things. So 4 is already there, 5 is already there, 6 is already there. So that's just the same. Oops. And then 4, 5, 6, union, 2, 3. So 2 is new, 3 is new, and 6 is already there. Right. And then the common elements of these two sets. So 2 is not there, 3 is there. Yeah, what I can do actually is remove stuff. So 3, 4, 5, 6. Okay, so just the 7 is not there. So that's what I get. And this is the same. So yay. We found, anyways, we proved in class, or we showed during using Venn diagrams that this was true. So in a way, it's just to pinch ourselves, to make sure we were not dreaming. So yes, it works. Yeah, so let's skip B for now and continue with the others, and then we can go back there. Okay, number 2. Yeah, what I'm going to do actually is just copy paste this. This is less painful. Okay. So let U be an universal set, A, B, C be subsets of U defined as follows. So U is 1, 2, 3, 4, 5. So did I put the same? Oh no, they are different. A is, no, they're all different. Yeah, actually that would have been good to just copy it. So U is 6. A is 1, 2, 3. B is 2, 3, 4. And C is 1, 5. Okay, so question is A, find following set. So that's so here it's really straightforward. You just have to make sure you don't make any mistake. How about you do A on your own a bit, and then you can check whether you got the right answer. Well, here I'm asking 2 things. Okay, all right. 2 things: A intersection B and A union C, and then A union C. Yeah, that's not too difficult actually. Yeah, maybe I'll do C, because then you have C is different since we have yeah, complements. So A inter C, somebody did that. Waiting for an answer. Are you sure about this? So we need common elements. Yes, good. So intersection C equals this intersection 1, 5. And so, yeah, it's just one line. So 1 is a common element, 2 is not there, and 3 is not there. So there's only 1. Yeah. Then let's try A union C. What's A union C? All right, let's try that. So yeah, I think that's it. Right? Yeah, also a trick in math is you can sort of do things in your head, but if you're really systematic and go step by step, you just write this. Okay, so let's write down what A is, write down what C is. And then, so if you do it, the more systematic you go, the less it is likely that you're going to make a mistake somewhere. Sometimes you may just miss some small detail there, but if you really do it line by line, it's better to make sure you don't forget stuff. So yeah, B is not so interesting. So let's go with C. Of course, we can go back if we have time. So complement of A intersection B. And A intersection complement of B. So let's, I'll give you some time to think about it. Four. All right, let's try that.
4 is for A intersection B. I mean, A complement intersection B.
All right, A complement intersection. Oh, intersection B. All right. Oh yeah, sorry. I didn't read the. Yeah, so one way to avoid mistakes is reading the question well. Reading comprehension is a prerequisite for this class, which clearly I should work on. All right, so let's try that. So let's just substitute stuff again. A is 1, 2, 3, and B is 2, 3, 4. So of course, let's start with that thing there. So complement is everything that's inside the universal set and not inside this set. So the universal set is 1, 2, 3, 4, 5, 6. So then what's not in 1, 2, 3 is 4, 5, 6. Right. So here I have this. And then this is equal to so there's only, yeah, there's only 4. So good job. And then let's go with the second one. I'll let you some time to think about it. Mr. Philip says 1, so let's check this out. So this is 1, 2, 3, and the complement of 2, 3, 4. So first of all, let's do this thing. 2, 3, 4. So the complement is 1, 5, 6. And then the intersection of this is, so 1 is common, 2 is not, 3 is not, so only 1. Yeah, nice, good. Good job. All right, so that was C. Then number 3. So I'm just going to copy this again. Yeah, I think the best thing may be to this. Then just have this full screen, that's better. And even I'm just going to share that part. Yeah, even can I, yeah, I think it's nice. This is nice. Okay, now we're in the business. Find what the set A equals A such that, oh yeah, so this was a bit different. So it's just that in the old version, I used, yeah, what's that name of that, colon, I think. But yeah, the vertical bar is what they use in the book, so that's what I want to use. So somebody have an idea about this? Think about it. So this is essentially saying, please express the set A as a simpler version of, we're using a simpler definition or simplified version of the simplified expression. Some ideas? Yeah, you're looking for any way to describe this in a more simple way. So yes, this is a set. So yeah. So please, we're looking for a set. Is this related to anything positive or negative? Oh yeah, I didn't say so, but yeah. Okay. So I could have so if I don't say so, assume A is element of the real numbers. So you could, so the more precise definition would have been A equals A such that A is the element of the real numbers and A cube is greater than 0 and A is smaller than 0. All right, so I'm going to ask somebody who doesn't talk too much. A is smaller than 0, smaller than A cube. So usually when we express something like this, we say something like 2 smaller than x smaller than 10. What this means is x is greater than 2 and x is smaller than 10. And since so of course we see that 2 is smaller than 10. So since x is greater than 2 and smaller than 10, then we can just order them this way. We can just write 2 smaller than x smaller than 10. So that will be one way to write it. Okay, so I'm just going to give you, it's good, the gears are grinding in your minds. So please, so if you don't know, if you're stuck, so first of all, try finding elements of the set A. So just before you start describing it, just get some example in mind. Find some number that would fit this definition. Okay, so I'm going to even go further and just let's collectively ask ourselves. So let's have these set of numbers. So -2, -1, 0, 1, 2. All right. So consider are they in A? So let's start with -2. Is that in A? No, not in A. Why?
I thought because a cube is negative, so it's not bigger than 0.
Yes. So here, what we're describing is we're saying that the set A is formed by a single valued element, so variables there, which must obey two conditions. We're just describing what the members of the set A have to fulfill to be part of A. One is that if you take its value cube, it must be greater than 0, and if you and the value itself must be smaller than 0. So because -2 cube equals minus. Yes, good. Jadbara found it. Good. So -2 cube equals -8, which is of course greater than 0. So it doesn't work. So I could try 0, for instance. So 0 is not in A because 0 cube equals 0, which is not greater than 0. And I could, for fun, let's try 1. So that's not in A either, because 1 is greater than 0. So that doesn't fit this, this condition there. So we can conclude that, so a simplified version of this is A equals the empty set. So, and just to convince you, I'm going to show you, let's go on the internet and show you. So, or let me just copy that. So you see that if a cube is greater than 0, so this is this is x cube, but it's like a cube. So you see that the only values that are greater than 0 are the values for which the variable is positive. So I'm looking for something that must be positive and also must be negative. So is there some value that corresponds to this? No. So it's there's an empty set. Something that may have worked is if I had used the greater or equal and smaller or equal. In that case, 0 would have worked because 0 cubed is 0 and 0 is equal to 0. So 0 would have, so I would have had this set there with just 0 inside it. But since I was strict, I said I want strictly greater or strictly smaller here, then it's empty set. All right. Questions about this? No. So you see that there can be many. So how many ways can I express the empty set in a million or an infinite different way? I can just say A is such that A cube is greater than 0 and A cube is smaller than 0. So nothing can be at the same time greater and smaller than 0, for instance. So any sort of, so when I am going to ask you, please express something, you may think, oh, maybe, but maybe there are different ways of expressing the same things. That's perfectly true. Yeah. Okay, so let me just make this a bit. So just to say what we're saying there. So the two conditions are incompatible. All right, so let's go with number 4. Form the Cartesian product of the following sets. The first one is 1, 2, 3, and yeah, 7, 8. Yeah, I can give you some time to think about it, but I'm not going to necessarily ask you. Maybe I can ask you just how many elements will the Cartesian product have, and then I can just write it down. Yeah, good. So that's 6. So let's just write them down. So there are going to be ordered pairs or tuples. So I'm going to have so that's, I would write this way. Oops. So that's a set. I start with sets and I end up with one set with elements 1, 7, 1, 8, then 2, 7, 2, 8, then 3, 7, 3, 8. And of course, the order doesn't matter. So I could perfectly have gone with the 2 7s together or the 3 7s together. So for instance, I could have ordered it this way. And then, yeah, 7, 7, 7, 8, 8, 8. You order it the way you like, as long as all the elements are inside it. All right, so it's really just a mechanical thing. Just learn it. And yeah, you combine all the elements in tuples, and that's it. That's how you do it. So are there any? Oh yeah, and let's do B2. So yeah, B, I changed the notation too. There was a plus that was like an indice, and that's kind of weird. So Z plus. Oops. So I would prefer doing it this way. Z plus. So I'm going to express it in different ways. So just think about it for a minute. Try and express it in one way that you would know how to express it. So by the way, Z plus, so Z plus are the positive integers. Oh, by the way, let me just check whether it's they include the 0 or not. That's just the okay. So yeah, I think it doesn't include the 0. So so you could say that Z plus equals 1, 2, 3, 4, that, and or is just equal to the natural numbers too. So yeah. So think about how you would just write it in your own way, and then I can give you different ways of writing it. Yeah. So this is not is the set of positive integers. And by the way, it's does something include 0 or not? It really is a matter of definitions. And so in the book, my impression is they say the natural numbers n here start at 1. So it does not start at 0. But I don't want to tell you, oh, you're a fool if you think that it could include 0. No, it is. So some people say it might, or it's really a matter of definition. So in the exam, I'm going to be, hopefully very clear about what I mean by the sets that I'm using. So I'm not, but if I forget to define, to remind you what the set is, so be reminded that the natural numbers don't include the 0 in this class. Or you can, if you're unsure, you say something like, I'm going to assume that the set you're giving me doesn't include the zeros, 0, for instance. All right, so I'm going to write different ways of writing it. So you could write it as Z plus cross Z plus. So this is a sort of the same way you would write this. And a more compact way would be Z plus squared. So here I'm using parentheses because having Z plus 2 is strange. So just to make sure, yeah. But as I said, it's like the natural number, so you could just say it's the natural number squared. And I'm going to also write it down this way. So you would say it's a set that contains what? Ordered pairs. So you could say it's say A and B. So it's a pair A and B, such that, so this is a sort of description of the elements, and then you can describe what the properties of each A and B are. So you would say something like sub, or maybe like Z1, Z2. That would be equivalent, such that Z1 is an element of Z plus, and same thing for Z2. So here, this is a description of the elements that you get inside this Cartesian product. Right. So you're saying it's a set of tuples made of two elements, Z1 and Z2, such that the first element is element of Z plus and the second element is an element of Z plus. All right. Questions about this? No, all right. So I could just give you some other things. So other example. So Cartesian product of let's say Z and oh yeah, by the way, this I should do this way. Z and R, for instance, that's perfectly allowed. That then what you would write is so it's exactly the same thing. It's just you replace Z by R. And then you cannot write squared here because those are different elements, the different sets. So that would make sense. But then you would say it's something like might be Z, small z and small r, such that small z is an element of C and small r is an element of which are the reals. So that's a neat way of writing it. All right, so you can write anything you like. You're free to write. And I don't know whether that would be useful, but I guess somebody could have a use for that. It's a weird set that includes just all numbers inside the first coordinate and fractional numbers, or yeah, any real numbers in the second one. All right, so let's finish briefly with the last question. So simplify the following expressions. So I have, so that's just to refresh yourself with all the exponent rules and square roots and stuff like that to make sure we're on the same page. So maybe it's you're going to find this easy, maybe not. So the 3 helps. So I leave you some time to think about it. If you don't remember the exponent rules or exponent rules or multiplication rules, please ask me. That's I'm here for you. Yeah, that's the right answer. So if the others want to just work a bit on it, I give you 20 seconds more, and then I'll show you how you do it. Yeah, all right. So yeah, that's the way to go. So this is equal to, and now the first rule is simply that if you have something with an exponent, so an exponent and then a parenthesis and then another exponent, you multiply the two exponents together. So that gives you, can just multiply it inside it. And so I have, so then this is just a fraction. So I can simplify the 2 and I get 3 minus 3. So that gives me x to the 3 times x to the minus 3. It's since it's the same thing, I can just rewrite x to the 3 minus 3. So it gives me x to the 0. That's of course equals to, so what is x to the 0? Yeah, so Philip says it's 1. It's 1 except for one value, if it's a real. So if x is 0, then we have no clue what this is. Because 0 to the 0 is undefined. So if you have anything, so if you have like 5 to the 0, it's equal to 1. And if you have 0 to the 1 million, then it's equal to 0. But so you see that like anything to the 0 should be equal to 1, and 0 to anything should be equal to 0. So then 0 to 0, is it equal to 1 or is it equal to 0? It's undefined. It's a bit like saying 0 divided by 0. So I'd rather, if you can do it without substituting, without saying anything about what x to the 0 may be, it's better. Just say, oh, I know for a fact that these two are going to cancel out, so I'm going to get 0. But yeah, I'm not going to blame you if you write this. It's a very technical point I'm making there, but just to keep this in mind. C, yeah, sure. All right, C. So, oh yeah, that's a complicated one. So 3 halves to the 3/5 times x to the 2/5 to the 5/3. Somebody has an idea about this? Yeah, so we have only 5 minutes, so I guess I can give you like 3 minutes, and then I can do it in 2 minutes. All right, 3. So let's try it. Yeah, this equals to, so the first rule here is, again, we have an exponent. So what this means is we are going to multiply the exponents of every term inside the parenthesis, which is since they're multiplied. So we can do that. So this is going to give us this. Whoa, what is that? Sorry. So the 3 cancel out and the 5 cancel out. So I just get 1 there, so I can just remove it. And here I get the 5 cancel out, but I get 2/3, right? And I don't think I can do anything more than that. Yeah, I think that's right. Okay. Well, how about we call it a day, since we only have 1 minute left. And anyways, I'm going to post the solution for the rest. So yeah, unless you have a specific request you really want me to explain. All right, so that was a pleasure. I'm going to post this session on Moodle, and yeah, next week you should have another TA. All right, so have a nice weekend, and good luck with the. So, oh, by the way, you cannot, of course, you cannot do all the assignment. You can just do the first section. The others we're going to see next week the material that allows you to do it. Okay, so have a nice rest, and I see you next week.